Hello friends, I am Praveen. I am studying VIT University. I am going to explain you now a few words about the data compression. The first of all, we have to know what is data compression. The data compression is nothing but the reducing the size of a data so that which we can helpful in the way when the storage is small and the data size is big. We can compress the data size and we can store it in that small area also. The compression is way to reduce the number of bits in a frame but retaining its own meaning. That means there will be a frame. The frame consists of the number of bits. But even though we are compressing that number of bits, the size of the originality and originality should remain the same. If we are compressing the data, if the data is what you can say, if it data is lost or its strings, what will happen? The originality will go on, so that the compression should be in the meaningful. What is advantages of that compression? They reduce the storage needed. Suppose for the 16 MB of data we have only the 4 MB of storage, so that we can reduce the 16 MB to 3 MB or 4 MB without the changing its originality. Reduce transmission cost, latency and bandwidth. That means what is meant by bandwidth? Bandwidth, everything in for a size of data, if the size is increased, the bandwidth also will be increased. Now we are going to see about the data compression methods. The data compression methods is of two types, the lossless method and lossy method. Under the lossless, which all data we can compress is the text or a program we can compress, and under the lossy we can compress the image, audio and video. For that they are following some three methods. Under the lossless they are following run length method, Hoofen method and Lempedziv method. Under the lossy they are following three types, JPEG method, MPEG method and MP3 method. And now we are going to see about the lossless compression. Lossless compression is nothing but we are constructing, but the originality should not be changed, and the perfectly it is the reconstructed from the compressed data. Once we are giving the data for compression, the originality should not be dispersed or they perfectly reconstruct from the compressed data. Redundant data is removed in compression and added during decomposition. During the compression, the redundant data, that means the duplication of a value, will be removed and added during the decomposition. Most lossless compression programs do two things in sequence. The first thing is statistical model for the input data. First we have to find the guess how the input will be given, and we have to reproduce that same input, but the size should be reduced. This is the main theme. Now the first method is Hoofen's run length encoding. This is the simplest method of compression. The first thing is replace the consecutive repeating occurrence of the symbol by one occurrence of the symbol itself, then follow the number of occurrence. That means, for example, they are give the originality data, they are give some sequence of data. Then we have to do is find the name of the data. That means B. For B, how much time it's repeated? It's repeated sometimes. It's repeated about 9 times. So B 9. And then we are going to A. A is repeated at 16 times. Likewise, we are compressing the data, and then by the compressing of data, then we are decomposing the data, and then by giving it is the first we are give the letter, and now we are giving the numbers, zeros and ones. That means the consecutive of numbers, the starting 0 to the consecutes, and we have to find that, and we have to suppose the 0 is repeated here at 14 times, and again the only one is repeated only once time, so we should not take that. And then we are taking the 0 has repeated 4 times, and then 1 has repeated 2 times, and again the 0 is repeated at 12 times. Likewise, we have to take the binary number of these data. The 14, the binary number of 14 is 110, and the binary number of 4 is 0100, and the binary number of 0 is 000, and the binary number of 12 is 1100. And now next we are going to see about Hoofan's method. In the Hoofan's method, the first we have to assign the favor bits to symbols that occurs more frequently, and more bits to symbols appear less often. And there is no unique Hoofan's code, and every Hoofan's code has some same average. And the first thing the algorithm is, we have to take each leaf node, and then from that leaf node we have to construct the main node. Likewise, we can see now. Now the Hoofan's algorithm. Hoofan's algorithm means they have give the character A, B, C, D, E, and they assign the number for the A as 17, and B as 12, and C as 7, and D as 27, and C also 12. And then first we have to make the node for everything, and then we have to find the which is repeating. Then in this, the B and C were repeating. The for value of B and C is 12. So the 12 and 12 plus 12 is 24. The 24 will be a parent node. And we have seen again which number is left back. At back side, the A is left and 17, and then we are adding the 12 and the 17, and it will form another one node. And then we are seeing that again which number is repeating. Then the D and C is repeating. The number of D and C is frequency number of D and C is 27. 27 plus 27, and it gives the 54. And then we are adding the 54, that a main leaf, and then we are getting another one main leaf. So that, and then what we are doing is, we are giving the binary number for each. 0 1 0 1 0 1 0 1, the frequency of 0 ones we are given. And for the A we are giving 0 0, and for B we are giving 0 1 0, and for C we are giving 0 1 1, and D we are giving 1 0, and from E we are getting 1 1. Now we are going to how the ending and encoding and decoding process take place. The first, we are getting the text is EA, EB, AE, CD and EA. The encoding, the value of A is given in the previous slide as 0 0. That which we are taken is the node value. Node value means the parent node and the child node value we have been taken. For A 0 0, and for D 1 0, and for B 0 1 0, and for E 1 1, and for C 0 1 1. Likewise, we are having the encoder number from the previous slide. And then now for E, what is the binary number 1 1, and for A, what is the binary number 0 0, and for B, what is the number 1 0 1 0. Likewise, we are arranging the Hoofan's code encoder for everything. And then for now we are going to do the decoding. The decoding is nothing but the consequent of binary number which you have got after the encoding, we have to convert it as now decoding. Now the number as taken 1100 1101 000 110 110 01100, and then as how we are encoded by using the binary number. Likewise, we have to again decode it. First we have taken 1 1. For 1 1, what will be the value? E. And for 0 0, and what will be value? A. Likewise, we are getting A, EA, EB, AE, CD, EA. That's only that. Now we have finished how the encoding and decoding process take place. Now the impulsive encoding. The impulsive encoding is consist of dictionary based encoding. What is meant by dictionary? Dictionary is nothing but the table based encoding. If both the sender and the receiver have the same copy of dictionary, if the sender also has the same copy of table, and the receiver also has got the same copy of a table, the previously encoded string can be substituted by their index of their dictionary. The previous encoding string can be substituted by their index number. The previous number of can be replaced for this. Now we are going like us continuing. This compression has two phases. Building an index dictionary, that means for each value we are fixing the index value and compressing a string of symbols, and that string has been converted as a symbols. Likewise, we are getting the algorithm for impulsive coding is extract the smallest string that can be found in remaining uncompressed string, store the substring in dictionary as a new entry and assign it an index value. Substring is placed with the index found in the dictionary and insert the index and last character of the substring into the compressed string. Now we are going to see the impulsive coding. Now the impulsive coding is, now they are given the uncompressed string BAA BA BBB A BB BBAA. That's only. And then now we are taking for the first the B and we are giving that as 1, and then we are taking as a next digit is A and we are giving as this number index number as a 2, and then we are getting next numbers A. The next numbers A means the previous number also is A, so that we are taking the again next number of A, then it will become AB and it will, we are giving this the term as 3, third index number, and then we are seeing next A is also repeated at the back, and B is also repeated at the back, and so we are taking a third number ABB and we are giving it as a 4 index number, and then we are seeing the next number is a B, it's a repeated, and the next number is A. The BA is not repeated and we are giving this number as 5, and then we are seeing next, and A is repeated, B is repeated, and again B is repeated, and then we are taking next number ABB is not repeated. Likewise at last we are taking BAA means that is ABB is repeated, and we are seeing the next number, this is a B, and the B is also repeated, and the A is also repeated, and the last number is A. We have been joining that number and we are getting the 7 dictionary labels. That means the seven types of paired strings. 7 types of paired string. What we can come, and then 7 types of paired strings, and then this we are compressing that string. That means B first is B, and second is BA, and third is BA, and the third number is AB. Whether which position is the A is there. The A is at the second position and B is not at there, and B is the new one, so that we are replacing it as BA to B, and then we are taking the fourth index is ABB. AB is what? Third, so 3B. Likewise we are doing till at the last, and we are getting the compressed form as BA, 2B, 3B, 1A, 4B, 5A. The impulsive compression is finished, and then we are going to lossy compression. Lossy compression is a converse of lossless data compression. The converse of lossless data compression means it will be the inverse of lossless compression data. It is used for compressing, that is used for what? Text or program compression, and it is used for what? Images and file compression. The method of lossy compression is JPEG, MP3, MPEG. JPEG means Joint Picture Exports Group. It compresses the pictures and graphics, and then MPEG means compresses video, moving picture experts group. MP3 is the as usual audio which we are listening through music. And method 1, JPEG encoding. JPEG encoding is used to compress the pictures and graphics. And first of all, I said that JPEG is nothing but the pictures. So that the JPEG coding is we are been compressing the pictures and graphics. In JPEG, a grayscale picture is divided into 8 into 8 pixel. That means then like a matrix form, row wise, column wise. That means 8 into 8, 8 into 8 pixels. And then the basic idea, change the picture into linear scales of numbers that reveals that redundancy. Redundancy is nothing but the repetition of data or duplication of data. The redundancy is removed by one of lossless. When the redundancy found, it is been removed. In that the formation is the first the black images will come, and then it will goes to the three phases, the DCT, quantizing and lossless compression, and then it will be given in compressed images. Now we are going to see what is meant by DCT, discrete cosine transform. That is, it will be arranged into 8 into 8 matrix, and it will be remove that redundancy. DCT transforms 64 values in 8 into 8 pixel blocks in a way that the relative relations between the pixels are kept but redundancy are revealed. That's only what I said. This is some block of images we are considered as a pixel. The pixel we have been expressed in the form of 8 into 8 matrix, that is 64 values, and then we are finding the redundancy, and we are been revealing that redundancy. And then quantizing, what is quantizing? Quantizing is nothing but the reducing the number of bits needed for encoding. For number of bits means the compressing, the main theme of compressing is reduce the bit. That only, by in this the quantizing we are creating the table, t table is created, and then the number of bits is reduced. The quantizing divides the number of bits by the constant. Each will have a constant, and we can divide by the constant, and we can get a fraction, and this done optimized number of zeros on each particular application. It is optimized. The compression, quantized value are read from table and redundant zeros are removed. And then by the quantized compression is occurred by the quantizing value. The quantizing value is the above phase which have been seen is quantization. In that some values will become after the redundancy, and then redundant zero are removed. The cluster of zeros together, the table read diagonally that after removing the redundancy, we have been by diagonally by zigzag way we have been calculating the compressions, and we are getting a new compression. So for example, we are getting that table t table, we are getting these numbers. By the zigzag way we are getting we are encoding, and the result will be 20, 15. Likewise the in zigzag way it will be their result. And method 2. Method 2 is MPEG encoding. Used to compress a video. MPEG means what? Moving picture experts groups. Moving picture is what? The videos. The videos is consist of the set of frames. The more set of frames is consist of is it reveals the video. Then the compressing, how its compression is occurs means the spatially compressed each frame, the temporarily compressed a set of frame. And then the type of MPEG compression. The type of MPEG compression is spatial compressions. Each frame is spatially compressed by JPEG. Temporary compression. Redundant frames are removed. The frames which is repeated are removed. For example, if we see this diagram, we are getting the redundancy. The green color is redundancy. The first one is yellow color, and then we are getting the two green color and one rose color and two green color and one yellow color. The combination of each color, the combination of more color will be known as the redundancy. And then we are giving it as some numbers. Some numbers means we are giving 1 for yellow, and 2 3 for green, and 4 for rose, and 5 6 for green, and 7 for yellow. Likewise the color which is repeating we have been cancelling that, or we are removing that. That is known as redundancy. Method 3, audio or MP3 encoding, used for speech or music. The speech is about the compressing. We can compress the speech about the 64 kilohertz digital signal, and the music for about compress about 1.4 megahertz signal. The two categories of techniques is predictive encoding and perceptual encoding. What is mean by predictive? The things which can be predicted before the encoding, and the perceptual is which cannot be predicted. And the predicted encoding is only the difference between the samples are encoded, not the whole sample values. The sample differences will be only encoded, but not the whole values. There are several standards they are following. They are following the GSM, that is the 13 kilobyte per second, and G729, and it is 8 kilobyte per second, and G723.3, and it is 6.4 or 5.3 kilobyte per second. And then perceptual encoding, it is a MP3. For example, the CD needs at 1.411 megabyte per second and cannot be sent over the internet without compression. But if we are sending through the internet, we have to compress it. For example, we are giving the 5 MB of data through the we are uploading in CD, we are uploading in internet. For uploading in internet takes time so much, and so we have to compress it. We have to compress it, and we have to make it small, and for the particular storage it should be fitted. Likewise, we have to compress. What is MP3? By MP3 uses perceptual encoding techniques to compress the data, that is MPEG audio layer 3. The thing which I have been discussed is very clear for you now, and I'm thank you.